9.2 says determine the value of x such that the total area of the page is a minimum. So what should the value of x be such that the total area of the page is a minimum? For that to be true, we're going to need to work with the first derivative, because we know that the area is minimum if the area is represented by a quadratic function, the area that is minimum will be represented by the lowest point, which is represented by a gradient of 0. So what we're going to look for is the first derivative of this function. And before we do that, we need to write it in such a way that we can get the derivative. So 3, 4, 5, 6, x to the power of minus 1 plus 6x plus 480. So if we get the first derivative of this, that will be this will be 3, 4, 5, 6 over x squared, because it's going to be minus 2 plus 6, like that. Now we want to equate this to 0. So 3, 4, 5, 6 over x squared plus 6 is equal to 0. Take the 6 to the other side and multiply by x squared. Then you get 3. So this is supposed to be negative 3, 4, 5, 6, since we multiplied by the negative 1 over there. So let's not forget that. Then from this point on, you can have negative 3, 4, 5, 6, and take the minus 6 to the other side, multiplied by x squared, we get that. And then what we can do here is divide both sides by minus 6, and then have x squared is equals to 3, 4, 5, 6 over 6, and then take the square root of that to get an x value of 576, or the square root of 576, which should give us an x value of 24 centimeters. So that's the minimum value that's the value of x that gives us a minimum value of our rectangle.